right, thanks, Randy. Happy to be here. I mean, what's not to like about talking radar and talking about land spouts? Oh man, those are fun. And hopefully through this case study, you'll see just how much fun these were. I'll talk a little bit about how operationally how we forecast for them and did an alert for them. But the bulk of this presentation is, the challenges associated with verifying something where there certainly wasn't a damage track. No chance of that, because there just wasn't enough trees and things in the path of these tornadoes to do any real damage. And what damage you had was spotty, but lots of challenges involved. And hopefully, as I talk about some of the best practices here, this can help. Some of these things might translate to some events that you all might have, not necessarily for land spouts per se, but maybe for tornadoes that you don't have damage tracks for, like clear damage tracks, a clear defined path of damage for. So an overview of the case that I'm going to talk about. This was May 20th of this year in the tornado central of Colorado. That's in Weld County. That's in north central Colorado along the Wyoming border. And we had an event where there were six, well, actually, we helped determine there were six. We didn't know in real time how many there were, obviously, but we determined there were 6 landspout tornadoes. All occurred within about an hour across a 30 square mile area of farmland, just north of Greeley, Colorado. And as I mentioned just a minute ago, we really only had 2 points of damage, and it was EF0, very minor damage consisting of some barn doors being blown in. The roof of a outbuilding structure was blown off. The structure wasn't the strongest built anyway, but it lost its roof mostly, just kind of flipped over. So not a whole lot to go off of in terms of where to start once we start the verification. And I'll go all into that. Most of this is on verification and how we did that. The other interesting thing is that all the tornadoes, from the videos we retrieved, they were all moving towards the northwest. So from southeast to northwest is the way they were moving. And go back to this, I wanted to show this one more time. The other interesting thing that I'll talk a lot about is that eyewitness accounts, while we can't live without them, we have to have those accounts. Sometimes they can be deceiving. Take this photo, for example. The person that took this photo, we determined, after doing a full analysis of the video, of the radar, and everything else that we had our hands on, this was taken about 10 miles from the tornado. If you look at the photo, it does look like the tornado is pretty darn close to being attached to the cloud base, right? Well, no, the looks can be deceiving. In actuality, that cloud base and the precipitation shield ended up being 6 to 8 miles away from where the tornado was at the ground. Even though this looks like they're all like really close, neat, connected and everything, it was certainly not that simple when you were close to it. So eyewitness accounts can be very deceiving, especially with high cloud bases like we have in Colorado and the crystal clear air that we happen to have this day, where you could see the tornadoes 20 miles away easily. Okay, so an outline, we'll talk about a quick overview of the setup and the real-time ops that we did for this event. The bulk of it's going to be the challenging journey towards verification, especially when you only had 2 points of damage and numerous videos and photos. And I don't want to make light of people that actually have obsessive compulsive disorder. I've never been diagnosed, but after verifying this event, I think I might have a touch of it. And it was actually very useful when verifying this event. And I'll explain why really attention to detail comes in handy for this. We have Chivo is a radar from Colorado State University. It's located in Fort Collins, not too far from where these tornadoes occurred. So I'll give a little radar analysis of what that radar happened to see. And finally, it's summarizing the best practices. I'm including this 500 millibar. It's just a NAM analysis off of wave. Really, it's nothing special other than I just wanted to show there's a trough upstream. Here's the location of the tornadoes. Denver, this is Weld County. And so there's a trough upstream, pretty good southwest flow, west-southwest or south-southwest flow aloft at 500. Actually favorable for supercells if it's about 40 knots a shear, 35, 40 knots a shear from 0 to 6 kilometers. And looking at the surface, again, for landspout tornadoes, the thing obviously that we care the most about is the location, the instability, and where are there some significant nearly stationary boundaries in place. And for this particular case, all that came together kind of in this red box area. So just to orient you, Weld County is this gigantic area. This is just part of Weld County. There's Greeley, it's a pretty big city. Fort Collins, another big city. And just along this area, just east of US 85, there was a really strong convergence zone on radar. We don't have a whole lot of OBS in this area, but suffice to say, east, southeast of that boundary, for us, this is pretty moist, low 50s dew points and low to mid 80s temperatures. So fairly juicy air for our standards here. And then to the west of the boundary, it was a lot drier. Dew points are in the 30s. There's actually a gust front that's a drier gust front, dew points in the 20s and 30s coming out of Wyoming to the north, from convection well north into Wyoming. And this boundary here, easily shown on radar, this boundary really clear on radar, then they collide in a little bit. And I'll show that on radar. So the 0 hour, the analysis from the HRRR using WAVE clearly shows that, when you check out the convergence in that little box there, it's pretty impressive. And again, that's from the gust front to the north, and then the nearly stationary moisture convergence boundary that lined up just east of US 85. So if you're looking, again, priming yourself for the event, that's a pretty darn good boundary that if we got convection on top of it, we'd have to be worried about landspout tornadoes. Here's the instability and convective inhibition, 0 SIN over the boxed area there. And CAPES were, this was right around 2,000 joules per kilogram. And I think the analysis might have been a little overdone in terms of how unstable it was, but as I'll show in a sounding next, a modified sounding, 2,000 was probably pretty close to what the conditions really were on the moist side of that boundary. So here's the Denver sounding taken at 0Z. The tornadoes were just after 6:30, so this is pretty darn close in time to what we'd expect from the tornadoes. However, Denver was on the dry side of that boundary. I mean, this is what we normally see, dew points in the 30s, ouch. But ahead of that boundary, if you throw in a dew point at just 50, so I just threw in a dew point of 50, nice high cloud base, but you can see quite a bit of CAPE available. And it's a lot of low-level CAPE too, actually, in the lowest parts of the near cloud base. All those point to a pretty good case to make for landspout tornado possibilities in that area. So we had a real good boundary, good instability on the boundary. We had a lot of things going for us here. So not the most comfortable calling it a dry line. But it sort of was, as we saw on the surface obs, it was like a dry line. It's certainly a moisture convergence boundary with very moist air on the east side. And apparently the insects on that day really like the moist side of the boundary, because on the dry side of the boundary, there was almost nothing to scatter the radar energy. East of the boundary, and again, this boundary lined up pretty well right along US 85, just east of it, and it didn't move a whole lot. The first signs of convection, at least of the precipitation from the convection that formed on the boundary, reaching the ground now several miles east of that boundary. We'll look at Cheyenne and Chivo radar next to see what the boundary looked like on the north side, because FTG was pretty far south of the radar. Just to orient you that the CSU's radar that we'll use quite a bit is located right here. And the area we care the most about is right in here. So Chivo had a really good view of it. Cheyenne was pretty far north of this area, but it just gives us another view. So here's a loop I'll let run through a couple times that shows the setup that we could see from the Cheyenne radar. Early on in the loop, and you'll see it again, there's that gust front from convection to the north, intersecting this moisture convergence boundary just east of US 85. And kind of watch what happens. I think if you let your eyes adjust, see that's kind of spinning a little bit in there. This whole, almost like a mesovortex spinning at the intersection of that northern gust front intersecting the moisture convergence boundary. Show it one more time. Again, hindsight helps here because we knew there were tornadoes in there. We're just trying to kind of explain where they were. Okay, yeah, so there's the oval one last time. The oval where all 6 tornadoes occurred. All right, zooming in a little bit in the area just to give you some scale. That's the box roughly where all 6 tornadoes occurred. It probably extended a little bit north of the north, but that really doesn't matter at this point. At 7:10 p.m., radar was showing Not a whole lot from Cheyenne. Granted, it's about 40 miles from here, maybe 45 miles. So it's hitting it 4,000 or 5,000, maybe 4,000 feet off the deck there. Actually, a little bit more because Cheyenne's the elevation of the radar is 6,000 feet. The elevation of the terrain here is about 4,300 feet, or no, 4,500 feet. So it's already pretty far off the ground. Our phones didn't really start ringing until around 7:10 p.m. And people are saying they see, you know, dust devil, tornado, landspout, all different terms for this in this box. Notice how far it is from the parent convection. So it took our forecasters quite a while. One to you know, they had to ask him, where are you looking at? Are you looking, you know, far off to the east, or are you looking, you know, exactly where are you looking? What are you seeing? What's happening? And it took a while to kind of confirm that indeed everything they were seeing was in this little area, well removed from the precipitation. So after finally seemingly a lot of confusing phone calls, it felt like conflicting evidence from eyewitnesses that were calling in. The evidence was compelling enough that we issued a Landspout SPS at 7:25 p.m. You know, after probably at least 10 minutes of, you know, going back and forth with spotters and what they were seeing. Just one final tornado occurred literally a minute or two after this was sent, and after that the event was over. So it was all within less than an hour time frame from start to finish. Another interesting thing is these storms that spawned, well, however the updrafts generated the tornadoes, the parent convection in that area actually was never severe for wind or for hail. Either one of those, it was never actually a severe thunderstorm. And as I mentioned, the Landspout tornadoes that we saw that day and verified were roughly 6 to 8 miles from where the precipitation was reaching the ground, well east. The precipitation was well east of those tornadoes. So definitely a challenging event. Thankfully, that all the tornadoes were very weak, and so there wasn't any significant threat to life and property, just some minor damage. So some of the getting into how we verified the event. Obviously, that was month 2 of COVID-19, when, gosh, we used to think April peaks were huge, right? Now the peaks are much worse now in the COVID again, but that was right in the middle of COVID. So not the easiest thing to do. We couldn't all huddle up in a group in our office and say, how are we going to attack this thing? We had to do that piece virtually. The nice thing is, huge team event, proud of the way our staff reacted to this. One of the nice things is we have a lead forecaster that lives not far, lives in Greeley. So he went on one of his, just happened to have time to do this the day after. He went and drove around at the few damage reports that we got. He saw those firsthand. And then he talked to a bunch of farmers and other locals in the area to see if they saw anything the day before. He was obviously socially distanced when he was doing that, but that was one of the huge benefits. Or not really a benefit, but one of the key pieces of this was having someone local that had time to do it that day. As I mentioned, from that lead image of the tornado, of one of the tornadoes, these things are viewable from 20 miles away, from just about every viewing angle, because they were 6 to 8 miles removed from the precipitation. You can see them from almost anywhere. But that also meant that judging the distance that witness was from the tornado, very, very difficult. Here's an example here of one we got. This eyewitness saw 2 tornadoes on the ground at the same time. I was able to locate where this person was based on the terrain, this particular bike path, and that neighborhood. That person was 18 miles from those 2 tornadoes, and it showed up that well. This just gives you an idea of how in the clear air and how sheared to the side from the convection the tornadoes were. I mean, there's plenty of blue sky behind that backlit this tornado. So the other thing that was helpful was social media. Even though they weren't tagging us, they would either hashtag tornado, or it was pretty obvious where they were just based on, we saw a lot of photos that resembled the stuff that we'd already gotten. So we were able to mine all the social media out there and grab images, timestamps, those types of things from social media. Thankfully, we have plenty of spotters in Weld County. Again, it's a tornado hotbed for Colorado. So lots of spotters, lots of chasers, and they used our NWS Boulder email to send us video and images. And we did a lot of back and forth with them, which was very, very helpful. We could not have verified this without those spotters and chasers and our staff that actually talked to those people to get what we needed from them. As I mentioned, we sent out lead forecaster Chad Gimestad, who lives in Greeley. That next day, he started the damage points, searched for others, but actually could not find any other damage in that box in the farmland of Weld County. Other than those two that we actually had. We had a video of it actually hitting a barn, and then another photo of it after it had already passed the barn. So he talked to a lot of people, but these are some of the images that we received. This one's useful because we could actually determine exactly where this person was. We went back and forth with him saying that, do you know exactly what time you took this photo? And sure enough, he had it all time stamped and everything. It was really nice. This chaser had really good views of 2 of the tornadoes. Let me play this video. So this is the action video taken from the same spot showing 2 tornadoes. We'll play it again. One tornado south of this particular highway. And then there's the tornado north, and the barn right there, just beyond that, was the one that got hit. And we actually have video of it getting hit by the first tornado. So part of the duty where you have super detail-oriented person, people, whatever, if you're very detail-oriented, from this video and others like it and photos, you can determine exactly where that person was. And then from there, hopefully, all you really need is a timestamp. And that's even if, let me put it this way, sometimes they weren't even sure where they were. Like, an interesting thing is that one of the chasers that was fantastic chaser, he had 20 minutes of video showing 3 different tornadoes as he drove around that boxed area in Weld County. On the video, you hear him say, I'm at Weld County 41 and 73 intersection. Well, actually, he wasn't. He was a mile east of there. And I verified that by checking his video with exactly where he was using Google Maps. So even he was wrong when he said where he thought he was. So it's always best if you can just verify using Google, and I'll get into more of that, the video and the photo. Chad got out there, so I lied earlier. He did find other damage that we didn't receive. There was damage to an irrigation pivot here from a couple of farmers that were working in their fields when 2 of the tornadoes actually touched down. So here she is in her tractor. She stopped what she was doing when she saw this first one form and filmed it for us. We would not have had this footage whatsoever because they didn't. She just took the video and said, oh, it's a tornado, big deal. I'm not going to send it anywhere. Because Chad went out there, talked to her and got information from her husband, we were able to get this initial video of where that one of these tornadoes touched down, the time that it touched down. And then she, 5 minutes later, she caught another tornado well off to her northeast, a second one. We were able to help pinpoint that. Never would have had that if Chad didn't go out and actually just talk to people and see what they saw. Very useful information. It turns out, so another EF0 damage to that irrigation pivot from one of the tornadoes that went over her farm. And the interesting thing is her husband was a mile east of her and also saw 2 different tornadoes. So 2 eyewitness accounts showing 2 different tornadoes. So we were pretty confident at least in this particular location that there were 2 tornadoes simultaneous. Chad also went out and talked to a high school student. Again, we never would have gotten this because he was happy to never skip couch day. He added that to his video. Never would have gotten these videos into our office if he didn't go out and talk to him. So let me play this one just as I talk over it. And check out the blue sky behind it. It was far removed. So this family was having a pretty good time looking at 2 tornadoes at the same time. So all in all, thanks to our lead forecaster going out there, thanks to other staff in our office that worked with chasers, went back and forth with them, we gathered all the information and dumped it into a Google Drive. We roughly had 15 videos, 30 other useful videos that were time-stamped, and we could try and determine where those were taken. Not all of them were time-stamped though, and sometimes we couldn't even determine that by reaching out to the people because we didn't have their information because they weren't spotters or chasers or anything like that. So part of this was just to be persistent about asking for timestamps and location where appropriate. And you don't want to be annoying, but for the most part, people are willing to tell you exactly where they were when they took the video, and they're happy to share that with you. But the trick is to keep being persistent. There were several times when we thought we had the right answer. Turns out it wasn't, so we had to go back and ask the person again, you know, exactly when was this photo taken? Where were you when you took this? And still, we couldn't get that information from a lot of the videos. So we used, this is where the real tedious part comes up. But it's also, if you put in the time and effort, you will be able to determine where each of these things were taken. So as I played this one, you can see someone's driving on one of the county roads in Weld County, looking at a tornado that's probably 3 to 4 miles away, give or take. And so you look for, when she does pan down, you look for buildings, other landmarks along the road. And then you can use Google Street View to determine, you know, where he or she is traveling. See a cross street coming up, nice red barn and that white building. That was really easy to determine where it was in Google Street View. And actually, and you also saw a road sign go, it was County Road 41. So that also helps you determine, okay, she's coming up, she's driving east, she's about to hit County Road 41, which goes south. Okay, we know exactly where she is. So using Google Street View, here's what I found. I guess this is a storage tank for the natural gas. It's a huge natural gas area out in Weld County. I froze the frame on that and then matched it up to Google Street View. Notice they're not exact, but that's because this particular one was, the Google Street View is 13 years old, unfortunately. So we are limited by when the last time Google Street View actually surveyed and took photographs of the local area there. However, even 13 years old, it was still very useful. I was able, she stopped her car in this parking lot and then filmed the tornado for the next 30 seconds or so. So I was able to determine exactly where she was when she parked and what the tornado looked like where she was, essentially right here. And then the other bonus is sometimes if you pause the video at the exact right time, she had her map up, I got the temperature, and I got the exact time she took the tornado shot. So really nice surprise. Sometimes those types of things just pop out of there if you go frame by frame. It is super tedious and you have to have time on your hands. I had a few admin shifts. It was COVID. I wasn't going to the office. Plus, I'm really anal about storm surveys. So I took my time and went frame by frame to make sure every single video, every photo was matched up time, space, and then we could start building a picture of where the tornadoes were and how many there were and when they occurred. So as I mentioned, given enough time or patience, you can locate nearly every one. This guy had a really good shot too. I guess we were lucky in some sense because, as I mentioned, there was one chaser that filmed 3 different tornadoes for 20 minutes, and I could tell exactly where he was after doing the magic with Google Maps. Thankfully, we had just other chasers that were just out there randomly in different spots at the right time, right place to see other tornadoes that they were the only ones that sent us evidence of it. And this was another one. This is well south of Highway 392. This is the last, probably the most significant tornado that most people saw. He happened to see it near the beginning of its life cycle, which was really nice. Plus, he had some good markers so I could figure out exactly where he was when he took that shot. Here's what so this Google Street View was about 2 years old, and it matches up perfectly with where the tornado was. So I was pretty confident with the location and timing of that particular tornado using Google Street Views. This particular one on the left, this is the one I mentioned that was, what, 15 to 18 miles away. I could tell she was on top of a hill, so I could use Google terrain to figure out where the hills were. We knew she was well west of where the tornadoes were. And then that bike path was key. I was able to see in Google Maps where the bike path was, Google Street View where that neighborhood was, and then matched it up pretty well, you know, way up here. See that? There's the bike path. This is the top of a hill, and she was parked on, there was a little dirt path right there. So I knew exactly where that person was when they took the photo and could kind of match up just how far away he or she was. Thankfully, that photo, the metadata was spot on. The timestamp was perfect, so I had a perfect evidence of where the timing of those two tornadoes at the same time. So still, that even after all of that, I would say that's still not enough for storm data. I mean, if there was no Chivo radar to help, we still would have had enough evidence to say, oh, there was probably anywhere between 4 and 8 tornadoes. I don't know if we could have narrowed it down more than that without having a radar nearby. Part of that was because, you know, we didn't have start and stop times. That was probably one of the hardest things to get, because most of the people photographing them did not see them when they first started. The tractor person was an exception, and then the chaser that filmed actually was the only person to see start stop of a single tornado that no one else saw. He was just in the right place at the right time. So we had to get lucky in a lot of different times, and we didn't get lucky enough to get the times of the tornadoes that we needed. The photos, though they are time stamped, hard to say where they were, and you're lucky if you're going to get more than one photo from the same spot. And still, with multiple tornadoes within a 45-minute time frame, hard to know which one was which. Tracks were pretty much useless because there were at least 2 witnesses that saw two tornadoes on the ground at the same time, and this was at different locations and times. In other words, we had evidence that we were confident that people saw 2 tornadoes at one particular time, and then 2 different tornadoes, not the same ones, at a different time, different location. So it's really hard to sort through all that. In many cases, you may be out of luck. You just do what you can, and we probably would have been able to do what we could had we not had the 5-centimeter Chivo radar not far from these storms. And that's what we're going to talk about next. So let me see time. Okay, good. It's a high quality C-band radar. It's 5-centimeter, located just northeast of Fort Collins. And so the tornadoes were right in this general area, quite a ways from Cheyenne, and really far from our FTG radar. It wasn't going to be any use. Even Cheyenne wasn't any use in real time, or even a post analysis. I didn't really see any evidence that said, oh, of course there's Landspout tornadoes there. Part of the deal with Chivo is that there's about a 5 to 7 minute delay from time to time getting that data into GR analyst into our office in real time. So we couldn't really use it in real time. I mean, you still can, but with that delay, it's challenging. There's a boatload of clutter to the west of the radar. So if we're trying to look at stuff in the Fort Collins area, it's challenging. But to the east, which is where those tornadoes were, it's actually really good close to the ground. So I mentioned we didn't really use Chivo in real time, so this is all armchair. This is all after the fact, post analysis. And even, let me put it this way, even if we did have Chivo data in real time, the signatures that we're talking about that it showed were about 20 knots gate to gate, or a VROT of maybe 10 to 12 knots. Time to time, the VROT got to about 20, but that was just 1 or 2 scans for one of the tornadoes. For the most part, they were extremely weak and really subtle. And really, I mean, the way I put it, the only reason some of these signatures sort of stood out was because I knew from photo or video that there was a tornado in that area. If I didn't know there was a tornado in that area, it was pretty hard to say, oh, clearly tornado. No, it really wasn't that way. It's very subtle, and you'll see what I mean in just a minute. And so what I did was, starting with the video and photos, I matched those up to what the radar looked like, and then kind of worked backwards. Did that signature exist in a previous volume scan, before that? So I was able to build a history of that particular tornado that we had evidence of. So I'll let this run for just a little bit because this is just fascinating to me. This is an 1.5 hour loop roughly that encompasses all 6 tornadoes and really shows that, remember Cheyenne radar showed a little rotational signature zipping right on down that boundary? Oh man, you can really see it. Because of the scan strategy, we got low level scans every minute or every 2 minutes roughly. So this is almost like a sales all the time it was running. And just keep watching. You can really see some of that rotational feature. And if you stare really carefully along that boundary, you can see little mesovortices, the Landspout tornadoes themselves it was detecting, or at least parts of it was detecting. They were still pretty small, but at that particular point, you'll see one particular rotational signature go right over it, right there. And that point when measured from the precip was 6 to 8 miles. So pretty much all these tornadoes that moved southeast to northwest were 6 to 8 miles from the precip. Fascinating. All right, so you go frame by frame with the radar and working backwards. So this particular storm chaser, after we determined where he was, the first tornado he saw was clearly to his south-southeast. He was looking, and it was way out there. No one else saw this first tornado. So based on the radar signature you see here, which, yeah, that's about 20 knots gate to gate. I'm not using storm relative for any of this, so it's just plain old velocity. So just keep that in your mind when you're looking at it. And then a little bit enhancement of reflectivity, which would, in theory, be the dust that kicked up, because all of these landspouts had quite a bit of brown dust associated with it. So we think Chivo might have seen that first tornado that no one else saw except this one particular chaser. He had it on video. That chaser was 1 mile from the next one, and notice it's not a bad, reflectivity is pretty weak, but actually rotational, there's a nice shear signature associated with the one he caught. And again, he's the only one that saw from start to finish this particular tornado that started right about here and moved a couple miles here. He saw it hit a barn and actually checked on the people that got hit. It was just barn door blown in right around here. Oh, and there's a kayak in the tree, a plastic kayak. That was the extent of the damage that was right here. But that particular guy was the only one that saw, but Chivo looks like it might have caught it. So it hits the farm there. The chaser looked due west at that. There may be another signature here. Again, the shear here is not the greatest, right? But it does have an enhancement in reflectivity. And then there's a really good, for this day, this was good, even further south. So this was, as we tracked this feature, I was pretty confident that this was the start of a tornado. So I was able to use Chivo to determine the general location and time of when this particular tornado started as it moved to the northeast. That video that I showed earlier is right here. The farmer was literally on that spot right there. That was her farmland. And so we're pretty confident that given it's a slight enhancement in reflectivity, shear signature, look, this one's still going, but no one's actually seen it yet, just the radar has. Stepping forward, there's that tractor again that she saw. Notice this signature is still going. It's coherent in time and space. I'll back up a couple. Using radar, you can track that. And then the same signature that we've tracked the last 10 minutes now or so, the farmer actually did film this well off to her northeast, at least a mile off to her northeast. Her husband also saw it, same time. He was in a different spot of their farm. And so we had pretty good confirmation. Thankfully, a couple other videos I showed, or photos, there was a chaser on 392. This is that highway. He's the one that saw a tornado to his south and a tornado to his north. This one, still nice coherent signature. This is a northern tornado. Still the northern tornado. This one's still going, and we still have video evidence of that one. Then here's where that chaser filmed tornado, north tornado, south tornado from his vantage point on 392. Same thing, the chaser on 392, thank God for him, because he was the one in the right place at the right time and caught that. So again, we're talking, now that's not a bad shear signature, right? That's about 35 knots next to zero. So that one is actually not bad. But interestingly, the dust or whatever was kicked up was a little bit weaker at this particular time. Another interesting thing we noticed that I shared with the radar engineers at Colorado State was that in a lot of these signatures, the reflectivity got knocked out. They just dropped it. And they weren't sure. Obviously, there's some kind of thresholding technique on the velocity and the reflectivity because it just gets knocked out there. But it turns out in those shear signatures where the reflectivity was relatively higher, we saw a dropout. So a lot of times I was able to track or help track, locate, or the evolution of the tornado based on these data dropouts. Now, granted, there's a big one down here that we don't think was anything because we didn't have any video or photo evidence of one existing down here or in the general path of it. Then we got, remember that one? Oh, it's 15 miles away. Yeah, so that person on top of a hill that was all the way in Loveland, her photo was at this particular time, again showing two shear signatures about where you would place them if you looked at her photo. And then we caught another one down here that no one has actually seen yet. This one is pretty much dead. No one else saw this particular tornado, and that chaser I mentioned was up here, so he would have seen it if he was looking. So pretty confident this one's dead. We have video from the chaser on 392 of that barn getting hit, and you actually see the debris from the barn. It was just, you know, aluminum siding pretty much, getting blown to the north as this thing crossed over it. But thanks to Chivo, again, with this new signature, and this is a really nice signature, again, based on what we saw that day, nice for this day. It's still super weak, and you wouldn't really call it much in real time, most likely, unless you're looking for it. But you can see very, very coherent, easily tracked. I also started noticing that, you know, really good timestamp video photos. Sometimes there was a parallax issue where the shear signature was maybe offset by a half mile to a mile of where we knew the tornado was on the ground. And my guess is that it's because, and you can see this in the videos, the tornadoes are really sheared. They're, you know, the location of the tornado loft is definitely not the same as the location right at the surface. It's definitely bent over. And so I'm guessing that the radar is hitting it at about 1,200 feet up when it's further away from where it is on the ground. So showing a quasi parallax issue when you're trying to really match up closely where the tornado might be. So obviously, when I built the tracks, the tornado tracks, there's going to be a mile error either way off this. Just especially if I had to use the radar to help determine where it was. A mile or two could be off in the tracks because there was hardly any damage in a lot of these, and because of uncertainty on where the viewer was at, where the tornado was relative to the viewer and on the radar. So lots of challenges there, but I think we got it pretty close. So that tornado 5 still looks pretty strong. A high school student, there's a little bit of confusion on which tornadoes the high school student saw. We think it was this one because he was a mile from it, but gosh, if you were, that high school student was close to 3 different tornadoes, like really close to 3 different tornadoes that day, based on what we saw on radar and based on what he sent us in video. At this particular time, we think just this 5th tornado is still going. And then you see that's actually a pretty decent signature that Chivo found. Still hasn't been photographed yet, but that's coming. Okay, then that only spotter in the area saw it at 7:05. He saw it again at 7:06. Again, he was here. He was looking to the northeast. You know, pretty good signature there, both the reflectivity. Again, it's just dust that causes that reflectivity, and then there's the shear. And then it's still going, and then the chaser that saw 3 different tornadoes that day, he was driving south trying to catch up to this one, and it was off in the distance, and he was looking to the southeast, so confident that he was seeing that one. And this guy parked and he was in the right spot, right time, saw it that whole time. We got a photo from Greeley, really nice shot this far away, same tornado, time stamped. We had 3 different people see this tornado at that time, and notice the shear signature. It's offset by about a half mile, as I mentioned. Again, probably that either in time or in location, the parallax effect from the radar beam hitting the tornado a little bit aloft. 3 different people saw that one. 5 different people saw this one at this time. We even got a photo from a chaser that was all the way up here that saw this one. So this one was pretty good, well photographed, well seen. Radar signatures are just kind of at this time, but given 5 different people saw it, we were confident it was where it was. Then this chaser caught it just as it was dissipating. He was trying to catch up to it again, and then it was pretty much gone by this time. So that's how making good use of 2-minute data, basically lowest scans of a radar can be useful if you have it available. Otherwise, you're kind of stuck with what you got, the photo and video evidence. So if you're interested, I'm sure you could share this presentation. We made a link to, there's a web page with this full write-up, and it's got the storm tracks, the best we could possibly piece them together based on the radar and the video and photo evidence. So let's get to some of those lessons learned. Hopefully some of this can translate to some events that you all might have, especially in areas where not a lot of damage indicators. if there's not a lot of trees around, open farmland, just grassland, which is what Weld County mostly is. Hopefully this could apply to you as well. For landspouts in operations, can't stress it enough. Just beware of those boundaries. With the right kind of boundary, lower all your thresholds for alerts, even just for landspout alerts. Those boundaries, especially if there's no convective inhibition, things can happen along those boundaries. We've seen that time and time again. For verifying these events, I guess like within the first 24 hours after this event, we had no idea how many tornadoes there were, nor like exactly where they were. So could not be in a hurry with verification. This type of analysis takes a lot of time. It takes 3 to 4 days afterwards, and going back and forth with the spotters and the chasers and verifying where they were, when they were, as best as you can. And obviously, I mean, if there's injuries and significant damage, you have to be in a hurry. That part I get. But in this particular case, this was more of like it was a huge curiosity in the media and in social media, you know, because a lot of people saw these tornadoes. They were very photogenic. So it was more of a curiosity. There wasn't any certainly no injuries, not a whole lot of damage. And thankfully, we had someone out there that was just talking to people. Without the damage indicators, we had to talk to people to see what they saw and when they saw it. We were very persistent with the spotters and chasers. Like I said, emails and direct messages are key, especially on social media when you're not going to know the person or know how to contact the person. We had to direct message them. And then I think the key piece of this that I think can translate to any damage survey if you don't have damage indicators or uncertainty on where the videos and photos were, that Google Street Maps view, even if it's 13 years old, can still be useful in identifying where that person was when they took the photo or video. Some of the eye-opening findings, I hope this kind of shocked you all as well, that this can be a landspout tornado. 10 dBz enhancement, so 10 dBz higher than its surroundings, 10 to 15 dBz higher than its surroundings, and maybe 20 knots a shear. That was it. That's all that was needed for these tornadoes. So having a close by radar obviously is helpful. Probably wouldn't have seen these, or we wouldn't even have this verification without Chivo, to be honest with you. Wouldn't have been able to do it. But it kind of blew me away a little bit that something that subtle, again, these were weak tornadoes, so we get that part of it, but that something that subtle was a tornado. The other interesting thing is that we hadn't really thought about before was, you know, in our minds, the conceptual model is, okay, there's the boundary. Tons of instability on the boundary, you know, there's shear on the boundary. Updraft goes up, stretches that vorticity into a tornado. So it's almost vertical, right? So the tornado's here, the storm's above it, you know, everything fits our mental model. In this case, not a chance. The mental model was that the tornado's on the ground here, and the stretching mechanism is 6 to 8 miles downstream to the east of where the surface tornado is. So kind of opened our eyes that, you know, weird things, or I shouldn't say weird, but unexpected things can happen with these boundaries. And when the storms are being sheared off to the east, you may not have a tornado anywhere near precipitation sometimes. So kind of eye-opening there that really floored me a little bit when we understood exactly what had happened there. All right, so now I've got time for questions, and thank you for letting me present this. This was a crazy event, but very, very interesting, and one that hopefully you can learn some best practices if you have something similar in a weak tornado with not much damage. So thank you.